In the last section, we saw how the natural number e arises from the compound interest formula. While we didn't show how the function converges to the number e, we did see the definition. In this section, we're going to see how the graph of the exponential with base e behaves. Let's start off with the definition of the natural exponential. And this is going to be given by f of x is equal to e raised to the x. This is also commonly known as just the exponential function. One thing to note is because the number e is greater than 2, by the previous section, the shape of this graph, the sketch of this graph, is going to look something like this. In this next example, again, we're going to go ahead and look at Mathematica. In this part, I'll go ahead and write out what we're evaluating. We want to evaluate the natural exponential e to the 5th, e to the 5.5, e to the 7th, and e to the 10th. Let me go ahead and write the Mathematica function real fast. And there'll be an associated video showing this computation in Mathematica. Again, first define our function as follows. And now, when we input the natural exponential, this has to be a capital E raised to the x power. Now that we define the values in Mathematica, we're just going to rewrite f of 5, f of 5.5, f of 7, and f of 10. So this is the Mathematica code. Let me go ahead and summarize what we're going to get out of this Mathematica program. F of 5 is approximately 148.4132. F of 5.5 is approximately 244.6919. F of 7 is approximately 1096.6331. F of 10 is also approximately 22026.5657. And that's the end of our evaluations. And to see this whole problem in Mathematica, see the Mathematica video. Let's practice some more transformations on a function by looking at transformations on the natural exponential. Let's sketch the graph of y is equal to e to the x plus 1 minus 3. All right. We're going to start off with our function y is equal to e to the x plus 1 minus 3. And we're just going to take off a transformation at a time till we get to the simplest possible function. Here we see that we have this negative 3 at the end, which means this is a shift downwards. So let's remove that real fast. We'll get y is equal to e to the x plus 1. Now we see that we have this plus 1 here. This is a shift to the left. Let's go ahead and remove that. And we're left with y is equal to e to the x. So now that we want to graph this, we're going to do this sequentially. We'll start with this graph, then we'll move to this graph, and then we'll apply the last transformation. So for number 1, we're graphing y is equal to e to the x, which again, because our base is larger than 2, by the previous section, our graph is going to look like the following exponential graph. Now, for part 2, what we're going to do is we're going to shift this graph to the left by 1 unit. So let me go ahead and make a copy of the function that we just drew. All right, so here's our graph. It would go right here, and then we're going to shift it over to the left by 1 unit. Now let's go ahead and look at the last graph. So this is going to be the sketch of the graph we're looking for. And we're going to look at graph number 2. And from here, we're going to take the graph of our green function and shift it down by 3 units. All right, so here was our graph before. We're going to take this and just push it down by 3 units. And this is going to be the sketch of our graph.